So now let's talk a little bit about something called sum notation. So this is just a way of writing down sums that's really common when you're studying calculus. So essentially we're looking at something like this, right? So we have some sequence of real numbers, so a list of real numbers, and we want to add these all up, right? So we use notation that looks like this, right? So this big kind of E looking symbol, that's called a sigma. Okay. On the bottom here, that tells you where to start your K values, right? So this K is actually called an index. And so this tells you where to start, right? The bottom tells you where to start. So this is telling me start with plugging in K equals 1. And the top part tells me where to end, right? Where to stop. So this tells me stop when you plug in K equals N, right? Whatever number N happens to be. Okay, so I have a couple of examples here. So for example, if I had something like this, okay, so inside of the sum, that's telling me what to plug into. So here I just have the number 2, and it's telling me plug into the number 2, K equals 1, K equals 2, K equals 3, and that's where I stop because of that 3 up there. Right, so now notice on this 2 here, there's no K showing up on in the inside there. So there's nothing to plug into. So you're just going to write the number 2 1 time, 2 times, 3 times. Right, so that's how you end up with this. And for something like this, now we do have something to plug into, right? We can plug into this K squared. Okay. So the first number I plug in tells me is told right here, right? So K equals minus 2, that's the first number I plug in. And I square it because this says K squared. The next number I plug in is minus 1, right? So you count up. So minus 1 squared, and then plus 0 squared, plus 1, so this should be squared, plus, so let me fix that right now. So it's squared, right? Plus 1 squared, plus 2 squared, plus 3 squared. Okay, and we stop at 3 precisely because this upper number is 3, right? So now you would add all of these numbers up, and then that's what the sum would be. Okay, so now these have some nice properties. So for example, up here, right, so we added the number 2 3 times, right, and that gave us 6. So essentially, if you're adding up the number 1 and you're writing it like this, you're adding up the number 1 n times because you're going from 1 to n. That gives you n, right? So 1 plus 1 plus 1 n times, that gives me n. I also have this property that says if I'm looking at a sum and it's being multiplied by some constant, I can pull that constant out, right? I can pull it out of the sum and just add up the terms inside the sum. Okay? I also have something like this that says if I'm summing up a sequence and the terms inside of there are being added, then I can split that up into 2. And then I have these really kind of handy formulas. So if I'm adding up the numbers from 1 to n, right, I'm going to just use this formula. And if I'm adding up the numbers from 1 to n squared, then I'm using this formula, right? So let me maybe give you a simple example of using this. So for this, so maybe I'm interested in summing up the numbers from 1 to 3, right? Let's pick something small. And I'm adding them up like that, right? So because this is just a K, that means I'm just plugging into K, right? So the first number I plug in is 1, plus the next number after that, 2, plus the next number after that, 3, and I'm going to stop there because this upper number here is 3, right? So I've got 1 plus 2 plus 3. So of course, if I add that all up, I get 6, right? But maybe this number on top is like 1 million, right? And you don't want to write down the numbers from 1 to 1 million and add them all up, right? It'll take you forever. So what you can do is use this formula instead, right? So we can use this. So if we used it in this case, notice n here is the number on top, right? Here's n and here's n. So the number on top here is n. So here this would be 3. And then the formula says n plus 1, so I'm going to do 3 plus 1, which is 4, and then divided by 2, right? And this 2 is always here, right? It's just part of the formula. So this 2 is always there, okay? This 6 is always there as well. Okay? So if I do this, right, I get 3 times 4, and then divided by 2, right? So 3 times 4 is 12, divided by 2 is 6, right? So I see that I get the same number. So let's look at a few more examples, right? So I wrote down some examples here. So I said determine the sum, so determine the value of the sums below, right? So we've got the sum from k equals 1 to 4 of 4 plus k, and we've got the sum from k equals 1 to 5 of 2k squared minus k. So I'll walk you through each step, right? So to get from here to here, we're using that property that says if I'm summing up something that's being added, I can just split it up and do one piece at a time, right? So here we go, splitting it up. Okay, so this is saying you're adding up the number 4 times, right? Because we're going from 1 to 4. So that's just really saying 4 times 4, right? Which gives you this 16. So here I'm adding up the numbers from 1 to 4, and I'm just adding the numbers k, right? So this is that formula that we just talked about. So we get, using that formula, 4 times 4 plus 1 over 2. That gives me 10, and then adding these two numbers up gives me 26. Okay. For the next example, we have something like this. So again, the first step is splitting them up, right? So here, this is what's on the inside of the sum. I can split it up into these two little pieces, okay? And on this first piece, actually, I also took that 2 and I pulled it outside of the sum, right? So now that 2 is hanging out outside. So for this sum right here, I can use that second formula on there, right? Which said n, okay? So our n is this upper limit, so n times n plus 1, that's 6, times 2n plus 1, right? So if you remember that formula, it's at 2n plus 1, so that's 11. Okay, and then always divided by 6, right? So this term right here is really this that's in parentheses. And then here we have that same formula from before, which tells us this is 5 times 5 plus 1 over 2. Okay, so do the arithmetic on this. This first term turns into 110. This next term turns into 15. They're being subtracted, so I end up with 95. Okay, so try now taking a look at